now we are diving into the world of finance with a session on how AI roles in transforming financial services and becoming essential. So please join me in welcoming our speakers. Fabrice Le Chatelier, Head of Data Science Office at BNP Paribas. Hanan, Ouazan, Partner and Generative AI Global Lead at Artefact. Ioan, Iacob, CEO and founder at FlowX.AI. And this session will be animated by Solène Brébant, investor at Balderton Capital. The floor is yours.
Hi everyone, thank you so much for joining our session today. So we're going to speak about the role of AI in transforming financial services. I'm going to be your moderator. I'm Solène Brébant. I'm an investor at Balderton Capital. We're a multi-stage fund investing from pre-seed to IPO in European founders. I'm going to let you introduce yourself first.
Yeah.
Fabrice. Yeah.
Okay, I'm Fabrice Le Chatelier. I'm working for BNP Paribas. I'm the head of the Data Science Office, and the Data Science Office is coordinating the work of roughly about 700, 800 AI professionals spread across the various entities of the group.
Hi everyone, my name is Hanan. I'm a partner at Artefact. Artefact is a data and AI consulting company, and I'm leading all our AI and Gen AI offers, and really happy to be with you today.
And hi everyone, thank you for inviting me today. I'm Ioan Iacob, I'm CEO and founder of FlowX. Been working with the same team of co-founders and core engineers for almost 2 decades now. And FlowX is a modernization, a banking modernization, multi-agent platform. We're going to talk a lot more about that.
Amazing. So, there is no denying that AI has a big impact in financial services, from fraud detection, risk management, customer experience, but there are also a lot of technical questions and challenges. So my first question will be, for each of you, could you share a specific example of a technical challenge that you faced while implementing AI in financial services? Fabrice, you want to go first?
Yeah, so we got some generic use cases, and they all basically ring the same bell. The first concern we have, the first thing to worry about is privacy, obviously. Privacy, because it's not specific to AI, it's to do with any data processing activity, so AI in particular. And we're using big data sets where lots of data, personal data, it could be also sensitive data, or even sensitive use cases. Okay, so which means that the traditional way of handling things, which is SaaS services, with AI, is not going to be an option for us, unfortunately. That's the first sort of challenge that we have. The second challenge that we have is with GPUs. I mean, it's just GPUs, electricity. We need to make very responsible, on those principles. We used to have this problem for training, and we would actually sequence the training, but now we have it for serving, so it's a different problem now. The third thing that we have also on AI is collaboration. We view AI as a collaborative exercise. So obviously IT is part of this. Okay, so we need the strength of IT, we need the robustness of IT. We need to deliver professional services, production-grade services. But there's also model developers, and quite often model developers are different people than the IT developers. They can be quants, in banks, or they can be data scientists. And even tomorrow, they can actually be citizen developers, people having used generative AI. And we need all those people to be working, in the same area and to collaborate.
Have you implemented specific tools or framework to overcome those challenges?
Yes, that's a good question. The thing we quite like is our cloud. Because when you're talking about collaborating, then the cloud is a great place because everyone's on sort of the same environment. Also, it's scalable, so it means it has a sort of responsible use of resources. You can actually utilize the resources. And also because it's a private cloud, it's something that we have at BNP Paribas, it's on premises, then in terms of privacy, it's ideal. And the reason why we can do this is, as I said in introduction, is that we have the critical mass to be doing this. We're talking about roughly about 800 AI professionals on the platform every day. We're talking about 20 different teams, 780 use cases that we have today. So we have the critical mass to be sort of self-sufficient on this cloud infrastructure.
Thank you. Hanan, you're working with very large groups. So what are the technical challenges that they face, and how do you help them overcome those challenges?
So I think I'm going to take the advantage to have Fabrice with me today to talk about the use case we've made with BNP. So there's a very interesting use case, what we call Smart Inbox. And the idea behind it is that as many banks, BNP receive a lot of emails every day. To give you a number, it's more than 20 million per year. So it's really a huge amount of emails. And these emails are routed to the right service in order to be treated. And because it's based on some rules in order to say, okay, when there's an issue about that topic, you go to that center, there might appear some issue in the routing process. So what we have done is that we have designed a new AI algorithm based on the best of hybrid approach between traditional NLP and more advanced LLMs in order to improve the way we route these emails. So how we did it, we basically train a simple classifier with this classification from NLP and LLM. And with this classifier, we are able to increase the number of emails that are routed correctly. To give you some numbers, we decrease the number of issues in the routing by 24%. And when you know that each routing error is 5 minutes time to reroute it, you can imagine the huge impact it is for 20 million emails. I made the math for you, okay? And basically, it's something around 14 years per year. So just to give you a number of the gain we do with that. And also, another thing that we have done with this project is because we have the capability to route correctly the email, we thought maybe we can also help the person that will handle this email to answer it more correctly. So we have adapted again a suggestion of answer for the advisor in order to gain time, and we get a metric of 80% accuracy on this advice. So about the challenges, because you've mentioned it, I think that the main challenge is the integration with the legacy ecosystem. We know that even for emails, even for everything, it's not that easy. And I think that another challenge is because we wanted to have adoption and have a huge user experience, we wanted the latency to be really small. And that's the reason why we didn't use an LLM or a traditional NLP model, but we use them in order to train a smaller model that is better just to do that task of classification. And I think that this in the implementation reduce a lot the latency of the AI, and then it's more a guarantee for adoption.
And how do you monitor this? Like, do you use any specific tools?
It's a right question. I think that the way we monitor it is just by tracking the number of emails that are routed correctly. So we have the number of emails that are rerouted. So we have noticed that we have a decrease by 24%, and also by being able to collect some feedback from the user directly and saying, okay, is the answer the AI provide you to answer more correctly? Is it better, not better? And that's why we get both quantitative and qualitative data about this project.
Thank you so much, Ioan. So you're the founder of a company that is actually helping those financial institutions. So what are the challenges that they're facing, and how can you help them?
Oh, definitely many changes. But in our case, we already have very large financial institutions, some of the largest financial institutions in the world, actually, using the FlowX.AI platform to build and run mission-critical applications in production. So, and for us to get there, probably the biggest challenge that we had to solve was how do you build an AI that is safe enough for banks to use, and to not just to use, but to use at the heart of their technology stack. And where we are today is fundamentally in a really outstanding place, and thanks to our engineering team, and we managed to have probably the highest accuracy AI enterprise platform on the market. We know that because we've benchmarked it, but we also are in a place where our AI has virtually zero hallucination. Now there's a couple of things that and again, you can't afford hallucinating when you're building technology and mission-critical technology for large financial institutions. It's just something, it's not acceptable. There's a couple of things that come to mind in terms of methods that we use to get there. So first of all was probably the first thing was chain of thought reasoning. So basically breaking bigger tasks into smaller tasks. So that agents or AI agents can tackle things that are smaller bites in size. The next thing has been self-reflection. So using self-reflection so that at the end of after completing every task, the agent can check whether the response after completing that task is still relevant. Probably the biggest impact has we've gotten from employing a strict RAG, retrieval augmented generation, so allowing agents to respond to requests only based on the data that has been provided by the bank and testing that. I think beside that there's been a lot of other things, like probably 80% of the time that we've spent building AI in the last couple of years has been focused on this idea, like how do you improve robustness, how do you improve reliability of.
And how do you show like the fact that you're super secure and that the platform is robust at the time of selling the products? Like how can you build this trust at the very beginning of the relationship?
Well, it's interesting you're asking that question, because the first reaction we get in conversations is this is too good to be true. Like it's literally and I remember we're listening to this podcast, and because we saw that they were tackling FlowX.AI, and like, well, like we never spoke to these people. I'm curious how they understand it, and that was like, this sounds too good to be true. But I want it to be true so badly. Like it could be true. It can be true. And I think it's we go through a very cumbersome sales process, because again, we put this literally at the heart of how people are building technology in these large banks. We go through countless committees, architectural reviews, and then the funny thing is, after we do all that, and our sales process probably takes like 9 months, 12 months, sometimes even more. The funny thing is, after we go through all those gates and all those architectural committees, and people start using the platform, their head explodes, and they're like, holy crap, it actually works. And I'm like, yeah, I thought you already knew that. But I think the state of enterprise software today and versus the enterprise, like somehow the enterprise software industry has failed the enterprise world in a way. Like they promised for such a long time, banks were promised platforms that would make their life easier, that would improve how they're working, that would make them agile and help them innovate faster. And the truth is, all they got was just another layer of complexity and another layer of lock-in, with more proprietary languages and proprietary infrastructure and vendor constraints. And so I think people are despite going through an incredible diligence before buying FlowX and before committing to using FlowX, it's always very surprising for us to see how people are still amazed by the power of the platform.
Amazing. Are you using any specific solutions at BNP, or like?
Such as FlowX. Yes, we have a mix of in-house and we buy also external vendors.
How do you choose between in-house and actually implementing another solution?
Yeah, that's a fair question. For some regulated models, we're being asked some explainability and some inner workings within the model, so we don't have a choice. We can't go external because sometimes it's difficult to ask the vendor, what his trade secret is. Okay, so you can't. So for those things which are, I would say, really strategic, we stick to in-house. For the sort of commodities, I'm talking about OCR, for instance, which, there's probably not much sense for BNP Paribas to, develop a skill to scan ID cards. Okay, well then in that case, we probably go to a vendor. It's a mix of, whether it's strategic or not, the cost, the benefits.
So maybe let's speak about legacy system, because the financial institutions have heavy, painful legacy systems. So how do you implement AI in legacy systems? What do you have specific quick wins, tweaks that you could share with the crowd here today?
I'll take this one. Yes, the cloud was instrumental in that respect, because what we said is when we started building AI, we used the cloud, our cloud extensively. So our lab was there, our people were there. This is where we started developing some APIs. And then basically all the sort of serving around this had to be migrated to the cloud to be nearby. And therefore we'd have a complete picture. In that process, we start using a lot of generative AI today to convert the code from old legacy systems to the new ones. This is something that is greatly helping as well.
I think that the last use case you mentioned, I think is the most interesting one. We know that there's a lot of legacy systems, and because there's a lot of legacy systems, there's a lot of old code inside these legacy systems, and it's really hard to maintain for two reasons. The first one is that because it's old legacy system, it's old language, and because it's old, it's a bit complicated to understand. I don't know how many of you have already programs, and if you know assembly language and you know Python, you know which one is the easiest one to understand. And that's why it's first really complicated to handle, and second, it's really complicated to maintain because again, it's old. The profiles that are able to maintain this kind of code are really rare. So it's a double pain. That's why I think that many companies are launching some projects around rewriting this code. And I have a public example of Auchan. Okay, it's not FSI, but I think that rewriting code is not specific to FSI. But they have made a public announcement about a project they've made, and they rewrite an old application using generative AI. Basically, they have designed a chatbot that helps developers to rewrite the application, to ask questions about it, and the numbers that they provide are really impressive. They mentioned the fact that without generative AI, it will take them 1 year just to rewrite one application, and with generative AI, they succeed to reduce the time by a factor 4. So it means that they only take 3 months to rewrite it, and it shows the impact this kind of technology can do on some really important topics like migration and code rewriting.
Super impressive. Do you have a view as well?
Well, absolutely. Like in our case, again, like every piece of software or every flow, every application, every mission critical platform that our customers are building on top of FlowX has to connect with tens, sometimes hundreds of systems. Because the truth is the data of large banks, large insurance companies is in all these old systems, and super interesting how fragmented it is, how overlapping it is, how inconsistent it is between systems. So one of the first things that we actually did was we created, well, again, over a decade of R&D with the engineering team. We've built this novel connector technology that enables our customers to create connectors very quickly to literally any type of existing system. So including, from APIs and databases and file systems all the way to mainframes or to even systems that don't expose data programmatically. And I love what you said, because one of the interesting challenges about mainframes is, the truth is everybody kind of points the finger at them, but we actually believe mainframe is an incredible technology, but it's just been bastardized horribly because a lot of people have put and have included things that should not be in the mainframes, like things that belong in a digital layer, like pricing or product configuration and all that. And connecting with these legacy systems that enables people to extract things that should not be in there and build them into digital applications on top. Now there's two probably key things that were super important for us in building this integration layer. One was having a dynamic data model. I think a lot of platforms suffer from the original sin that they evolved from some type of business point solution, like a CRM solution or a ticket management solution, and they're paying tribute to having that fixed data model at the core of their platform. In our case, we have a dynamic data model that gets built as you integrate, as you connect more systems. And the second thing is, one of the things I realized is all these systems that contain data, they have not, like most of them have not been built for the digital age. They have not been built for literally billions or tens of billions of transactions per day that are required in today's world. So probably a very important thing is that our integration layer functions as a robustness and resilience layer on top of these systems, so kind of protecting them from overload, so pulling and queuing requests and doing like an intelligent management of those requests. So for us, those two things have been key, the dynamic data model and creating like a resilience layer.
Do you have any other like solutions like this that you've used to deal with those challenges? No?
Not that I'm aware of, no.
No, I think there's many solutions that exist, and I think that an interesting part maybe is also how you mentioned it earlier, how you maintain all these applications, and I think this is also something that I think is really important. We know that these systems are prone to hallucination. You mentioned it, there's not 100% relevant if we don't do it correctly. And we know that in the FSI industry, it's really complicated because there's more privacy, more security, and we need to be really hard and really strict with hallucinations. And something I like to talk about is to give you a metaphor about how much is really important and how we deal with that in practice. Maybe can you raise your hand if some of you have a driving license? How many of you have a driving license? Okay, so many of you have a driving license. It's a good news, I know, but maybe you forget it, but I will remember for you when you get it, it took time to get it. You had to pass first a writing exam to learn a lot of things that are not really helpful sometimes, but to know them and to have a really good grade when you pass the exam. And then after this exam, you had to train to how to drive, then to pass another exam on the field with your car. And maybe some of you have taken this exam many times, and you know how much this process is complicated. But even with that, today you have your driving license. Okay, many of you have this driving license, but I'm sure that everyone that here has a driving license have also received a contravention or have lost some points on their permit for sure. Don't fool me. I'm sure that you have you belong to this category as well. And that translates two things. First is that how good you are to learn how to drive, you will make errors. And it's exactly the same with AI. With human, we know that there's no 0% error. We know that human is making error, and we have created a legal thing in order to deal with this issue. That's why you have radars, you have policemen, you have policewomen in the street to be sure that the law is established. Okay? And we need to do exactly the same with AI. How we do it with AI? First, in the design of the AI, as you mentioned earlier, it's really interesting. You need to be sure that you feed the AI with the right data. You need to be sure that the data that is fed to the AI is a good data with no quality issue. You need to be sure that the prompt you write, in order to be sure that the prompt of the system is well written and is really clear. You need to be sure that if you connect your AI to many applications, the connection is making in a good way. The AI knows that it needs to connect to that system for that reason. And if you do a chain of thoughts or an agentic pattern, you need to explain really simply and really correctly how to do it. And this is exactly like you when you learn how to drive. You need to be very, very, very specific and very strict and very detailed on how you build your AI. But as human, AI can make errors, and that's why you need, after putting AI in production, to have this observability and this eye on the AI in order to be sure that it behaves well in production. And how we do it, basically, it's a three-layer approach. We, at the beginning, monitor everything. So it's a very IT process. We log every interaction of the AI. For example, you put a chatbot in production. You need to store every interaction of this chatbot. So Mr. Dupont has talked with the chatbot. This is what he said. This is the answer of the AI. The AI had made a RAG process to get this chunk of data, etc., etc., etc. You log everything. And you also log the time, the latency, the cost of this interaction. After this step of logging, you have the evaluation steps. And in the steps, you will evaluate not only the quality of your answer, for example, the RAG process works really well, the answer correctly the question, but also, also to know that the cost is acceptable for this interaction, or the latency was acceptable, and this is the second layer. And the third layer, and I think that this is the most important one, the most underrated one, and also I think that the one that I never seen everywhere, but is really important, is this supervision layer. And supervision layer is a layer that is managed by the business, and basically it can be designed with a simple dashboard, but you have a big picture of your AI system, saying, okay, this is the number of interactions you have today, this is the topics of your chatbot, this is where your chatbot have made errors, and this is the reason why this chatbot have made error. And the AI is capable of telling you, okay, the reason why your chatbot made an error is because your chunks are too small, or because your RAG is not good, or because your ranking algorithm is not good. And we have today the kind of technology to help us to do that. And I think that it's really important to have this observability layer, because without that, we can put AI in production. It's exactly the same. Without radars and policemen, etc., I'm sure that no one will drive at 50 kilometers per hour in the peripheric. That's the same concept, and I think it's really important to keep that in mind, because this is a guarantee to put AI in production.
No, definitely. I mean, I imagine that reliability, accuracy, compliance are big challenges for you as well. Do you also have any solutions or systems in place?
There's a practice which we quite like, is human in the loop, as you said. I think we found that from experience that combining human expertise with AI works very well in terms of performance, but also in terms of acceptability. This is the kind of thing that works well.
Ioan, I think we have only 2 minutes left, so if you have anything else to say?
Yeah. No. Again, because we're using our AI at build time, and the IT teams in banks are using our AI at build time. We've actually gone beyond this idea of human in loop, where we're calling it human in control. So literally every output of the AI agents can be checked, and it was a very interesting challenge how to design the journey and the user experience around creating that, making something that people feel safe about. Because sure, you can create very safe technology, but how do you also make the people feel safe? And since we're in the automotive analogies, you know how Tesla has a big screen up front where you see what the computer vision understands of the real world. If you think about it, there's no functional reason for which that exists. It's not helping people functionally. However, what does that create? It creates confidence. It creates confidence that, yes, the computer, the machine, understands the world and sees the world exactly like I do it. So you tend to give it more and more freedom, and you tend to, and pretty much the similar, like we've gone through countless kind of design and iterations around user experience in AI, and embedding that human in control has been super important for us.
Thank you so much. I think it's the end of our panel, so thank you everyone.
Thank you very much. Thank you, Fabrice, Hanan, Ioan, and Solène for your time and for this session.